Newton's second law. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. So, when the forces are unbalanced acting on an object, there is a net force. Now, if there is a net force, the force will have an acceleration. So the net force will produce an acceleration. The direction of motion of the net force will be the same as the direction of the acceleration. The acceleration of the object will depend upon the net force. So the acceleration is directly proportional to the net force. And also, the acceleration is dependent indirectly upon the mass. So the acceleration is inversely dependent upon the mass. So that is how they are dependent to each other. That means that if the acceleration increases, the force also increases. If the net force increases, the acceleration also increases. Whereas, if the mass increases, the acceleration will decrease. Vice versa, or vice versa, if the acceleration increases, the mass will decrease. Newton's second law of motion can be formally stated as follows. The acceleration of an object is produced by a net force that is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. This acceleration can be expressed in an equation as F net, or the net force, divided by the mass. Now, if we are going to rearrange the equation, this would be the net force is equal to the product of the mass times the acceleration. So that means if the mass is increased, then force also increases. They have a direct relationship. And if the acceleration is increased, the net force also increased. Whereas the mass and the acceleration have an indirectly proportional relationship, which means if the mass increases, the acceleration decreases. If the mass decreases, the acceleration increases, or vice versa. If we express the acceleration as an equation, we will have A, the acceleration is equal to the net force divided by the mass. Rearranging the equation would tell us the net force is equal to the mass times the acceleration. So, the mass is directly proportional to the net force, which means that if the mass increases, considering the acceleration is constant, if the mass increases, the net force would also increase. If the mass decreases, the net force would also decrease. Then, if we held the mass constant, the acceleration is also directly proportional to the net force. If the acceleration increases, then the net force will also increase. Or the other way around, if the force increases, then the acceleration increased. The mass and the acceleration have an indirect relationship, which means that considering we held the net force constant, if the mass increases, the acceleration will decrease. If the mass decreases, the acceleration will increase. So the other way around, if the acceleration increases, the mass would decrease. If the acceleration decreases, the mass would increase. Or if the acceleration increases, the mass would decrease. Now, using this formula, we can apply some numbers and find the acceleration. If you have a net force of 10 newtons, a mass of 2 kilograms, what would be the acceleration? So, looking at the table, we can see that our acceleration would be 5, right? It would be 5 meters per second per second. Now, if the net force is 20 and the mass is 2, what do you think will be the acceleration? So that would be 10, right? 2 times 10 is 20. Okay? Now, supposing we have a net force of 20 and a mass of 4. So, what would be the acceleration? It would be 5, right? So, looking at the values, if this is the net force and you double the net force, considering a constant mass, then the acceleration will also double. So, if you hold the acceleration constant here, you hold the acceleration constant, and you double the mass, then the net force also doubles. So that's how the second law of motion is applied to the table. So the table tells us that comparing the values of rows 1 and 2, it can be seen that if mass is held constant, if you double the force, then the acceleration also doubles.